Everyone, this is Andrei Oros from the UiPath product team. The robot autoscaling solution is implemented on top of the official UiPath IT automation activities that empower us to automate all areas of our IT ecosystem, from on-premise data centers to public clouds. The activities are background running, implemented on top of the official SDKs from vendors such as Microsoft, VMware, etc. They are background running, very fast, secure, and they're free to download from the official UiPath activities feed. The robot autoscaling solution, since it's a workflow-based one, can be easily deployed in all types of infrastructures, from on-prem, private, public clouds to UiPath's RPA cloud. The IT automation workflows that make up the solution are very easy to understand. The business logic is clear, they're very transparent and easy to audit. They're flexible, you can customize them to adjust them to your particular needs. And they're vendor agnostic because we have activities to manage infrastructure, virtual machine servers from all the major technology providers such as Microsoft, Amazon, VMware, Citrix, etc. We also trust this type of workflows internally. We are using them mostly for cost control areas, use cases, especially in cloud, in Azure, and also to take some load off our cybersecurity department. We have automated the mitigation of brute force attacks on Azure public-facing VMs, and in the last 6 months it has processed automatically over 15,000 attacks. This type of IT automation workflow templates and even more can be downloaded for free from the Connect marketplace from this URL, and they will help you accelerate your automation journey when talking about use cases from this area. The robot autoscaling solution components, the three main ones are the database in which we add our clients' information, the clients that we want to manage. Basically, we need information about the orchestrator API, the client key, user key, etc., the URLs, since we want this solution to be able to address deployments from any type of infrastructure. The robot counts, how many robots you want to be always running, how many of them you want to be allocated only on demand, and we need the infrastructure type as well. Events such as job created, faulted, stop, etc. from our managed clients end up in a queue in the management orchestrator via a webhook receiver service. This can be anything from a function in the cloud to a self-hosted web service. The code is available. It's very easy to inspect it, change it. All it does, it forwards requests that come from the managed client's webhooks. It forwards them to our events queue from the management orchestrator. And the data that it forwards is very simple. We only need tenant ID, event ID, folder ID, the information about the process, so that we can identify also the environment for the managed client. There are three main scaling strategies. The first one, the most costly one, favors robots availability so that it takes on a pending job as soon as possible. This means that the robot machine is powered on, the OS is loaded, the robot connected to the orchestrator, and we have at the opposite end an allocation on demand strategy, which means that the robot machine is provisioned. It has the robot installed and configured, connected to the orchestrator. However, the VM is deallocated or stopped. The robot and its associated virtual machine will be brought online only when we have incoming pending jobs. What we've seen in practice is that actually at the customers, partners, they will favor a strategy that has some of both, meaning that there will be some machines that will be always kept running, no matter if there are 0 pending jobs or not, and the rest of them will be allocated on demand. You can define this type of strategies, how many robot machines you want running or not, via the hot cold virtual robots that you define in the database for your client. A hot robot implies that the machine on which it is running will be kept online, um, so that if there are incoming pending jobs, the time to ready, the time to allocation is as close as possible to zero. If a robot is defined as cold, basically when it is allocated for a pending job, it will take around about 2 or 3 minutes until the pending job is started. This depends on the size of the VM, the server's configuration, and yeah, on a number of factors. But these are some numbers that we've taken from the reference VM D2B3 from Azure. Now, if there would be no pending jobs for a VM of this size, and we wouldn't allocate it at all for a month, we would only pay for it the storage part, around $2. However, if it would be running the entire month, you see how easy the costs add up. So $160 multiplied by the number of machines on which the hot robots run, yeah, you can easily end up with a big number. So the potential for efficiency, for optimization, for cost saving is with this type of solution is huge, the bigger your infrastructure. Now, the scaling strategy, it takes into account pending jobs. This is the foundation for the solution, the pending jobs and the events that come from them. And this pending jobs counter basically gives us the state of the managed client together with the list and number of robots that are available, connected, disconnected, busy. The lower part, hot, cold robots counters, basically make up your scaling strategy. The solution is really flexible from another point of view as well. You could dynamically change those counters in the database for your managed client based on usage data. Let's say you have insights and you identify some usage patterns. You see that at the end of each month there are a lot more job requests than the rest of the weeks, and you know that you will need in that period X number of robots. You could easily schedule a workflow, a job that automates that database entry for your managed client to update, to edit the hot robots count only for that interval and the cold ones, and for the rest of the month to keep it with a higher number for the cold robots. So it's really easy to adjust the scaling strategies to your needs, and this in this particular example to your usage patterns if you know them. If you need even more customization, since the solution is a workflow based one and you get from us all the source files, you can easily change the workflows to match your custom use case. The scaling part is clear to understand. The IT infrastructure one is even easier, and yeah, it's a really powerful way, and it enables you to adjust the solution in such a way that it is compliant with your internal IT policies, and yeah, you can adapt it to basically any needs. Let's talk about the process flow. So as I said, everything starts with events emitted by job requests from the managed clients. These events are forwarded via webhooks to our webhook events receiver service, where we read the information from the event, such as tenant ID, folder ID, job created. And afterwards, we make an API call to the management orchestrator to add this data, this event data, to our queue with new webhook events. This will trigger a new job that processes queue events via a trigger we configure. And this is where the heavy lifting happens. This job will retrieve the event data for the first queue item. We have FIFO for the queues in our orchestrator. We also get the other associated queue items, associated meaning that they belong to the same tenant, to the same folder, and maybe even to the same environment, so that we mark them all as processed in order to minimize concurrency situations. And afterwards, we retrieve the client information from the database. We have all the necessary information, tenant ID, folder ID, environment, to identify the tenant in the client's list in the database. And we read from there the connection data for its orchestrator. And then we proceed at step 4.4 to retrieving its state, to retrieving the pending jobs, the available robots, disconnected robots, etc. Since we now have all the information, we have the state of that managed client plus the scaling strategy from the database, we can proceed to select the virtual machines or the servers on which we want to apply auto-scaling, either allocation or deallocation. And IT automation-based workflows will do just that. They will power on, power off machine 1, 2, 3, and whatever, in order to to optimize the number of robots based on how many pending jobs there are and how many hot and cold robots you've defined in the database. As you can see from this picture, we support high density robots, meaning that the counters that you add to the database, hot, cold robots, are not one-on-one with the machine. So you can have on one machine multiple robots. What we do with the solution, we try to keep available for you, in the case of hot robots, the minimum number of machines so that the hot robots counter is met. And the same when we deallocate. So we support high density robot situations. Also, if we take a look in the database clients area, you see that I've added here client 1 2 times. Why? So client 1 in this case, in this example, has 2 entries set because I want for client 1, folder 1 different rules for auto scaling compared to folder 2. So you can do auto scale, and you can have different auto scaling strategies for the same managed client at folder level and even at environment level. So let's say I would have had another entry for client 1 on the same folder 2, but for environment E3. And that environment maybe would have been on VMware, and they would have had different values for robot hot and cold. And of course there can be other client 5, 10, etc. So you can manage with one deployment of this solution multiple clients, multiple tenants that have machines on all types of infrastructures deployed both in cloud and on premises, as you can see here. So this is the main flow of the solution, and this is how everything connects and works together in one picture. And if you take a look at the solutions project files, you will easily identify what's shown in the previous diagram. The flow is really easy to read. The solution can be downloaded for free from our Connect marketplace. We offer everything from the source files, a guide to help you configure this step by step. We even give you some auto-scaling recommendations. Deploying it on your site should be straightforward. It implies 3 main steps. You need to configure the management orchestrator, to upload the process package, create the assets from the list, have at least 1 robot, create the queue, and add a trigger on new item created to start the auto-scaling associated process, a job for it. And you have to configure a webhooks receiver service. The easiest way would be, if possible, with a function in any cloud of your choosing. And of course you have to deploy the database. We provide you with a script for it, and yeah, add clients. All right, now let's see the solution in action. I've prepared for our demo 2 clients, one in Amazon and AWS and one in Azure. The clients orchestrators are on the top right with the light team, and the management orchestrator, the one that reacts to events incoming from the clients, is the one with the dark team on the bottom right. Now I will proceed and start a fake job, and I will tell it explicitly that I want it to run on these instances, on these robots from these instances in Azure, in Amazon. Start. And in Azure, I'm going to select another process, and I'm going to allocate dynamically 3 instances. Now, what this will do, it will forward these events that are created for the pending jobs via the webhooks mechanism through our webhooks receiver service, and in turn, after they end up in the queue, the new items will for the events will trigger process queue items job. These jobs, they will select for each of the 2 managed clients some machines to power on or off. In our case, it will be for sure power on. And let's see. Okay, so we see that in AWS, the robot instances are already being initialized. We're going to see the same in Azure shortly for the 3 virtual machines that belong to this managed tenant. Let's see. Okay, here it is. So here we see the log for the Amazon AWS client from this demo. You can see that it identified that it had 3 disconnected machines. Then it retrieved the AWS credentials from the manage orchestrator assets. It used them to connect to AWS and to start the instances it selected for the pending jobs. So from an audit point of view, this solution is really powerful because you get logs, audit trails at both queue item level. And let's see how the queue items from these events look like. And you also get it at jobs level. So here you see my process fake work with this ID from this folder, from this tenant. So this is what's been forwarded from the webhooks receiver service, basically the Azure function that I'm using for this. And this triggers the pending job, the processing job via a trigger on new item added. In this solution, in this deployment, I'm actually managing more than the 2 clients that I'm using for the demo. But for these 2 particular clients that I've pre-selected here, you can see that for AWS, I've defined that I want 4 cold robots, and for Azure, 3 cold robots. Again, if I would edit now these values on the fly, the next trigger for processing an event would take into consideration the new edited values. So it's really easy to customize if you have know-how regarding the usage, your robot's usage. All right, now let us wait until the events get processed and take a look inside the workflows that do all these actions. The Autoscaling project, the solutions project, has a lot of components that perform granular operations related to our orchestrator, getting environments for for a process, getting the folder ID, authentication token, so forth. And we also have for the infrastructures that we can manage, we have workflows, really easy to understand ones for managing the state of a virtual machine. Let's take AWS for instance. In this area, I'm retrieving the assets for connecting to AWS. I'm retrieving my selected instance, and based on the in argument that tells me what I want to do with that instance, because I'm reusing this workflow for both allocation and deallocation, I'm starting the instance or I'm stopping the instance. From a scaling strategy point of view, here I'm retrieving the database information for a selected client. I'm authenticating against its orchestrator API. I'm getting my token. I'm retrieving the state for this managed client. And by state I mean robots and their state pending jobs. And I'm outputting all these for reuse in the main workflows. And then in this area we have the main scaling strategy flowchart. If I have pending jobs, I'm not gonna disconnect anything, but if pending jobs is 0, I have a workflow that I invoke with disconnected or available, and basically I'm reusing it for both operations, and it's selecting for me based on existing running workflows, available robots, etc. Basically based on the state, it's selecting for me some virtual machines that will be later used to apply the desired action scale up, so to start them, or scale down to power them off. And you see here the selected VMs list output. Okay, let's return now to our environment. As you can see here, the AWS pending jobs for the client from AWS are now ready, successfully executed, and this triggered another event. That event started a processing job, and that processing job saw that the event said job completed, the client's event, and then it decided that for AWS, since I've said here that I want for cold robots, it can safely go ahead and stop these instances for me. I'm looking forward for you to try this, to give it a shot, and let me know what you think. Thank you very much.